Hello and welcome to proof of composite reflections over parallel lines. So please bear in mind that what we're doing here is proving for the most general case that when you reflect over parallel lines, that is when you go do a composite reflection over first one line, followed by a reflection over another line, right, on some point A, that is equivalent to a translation of 2 times the distance on point A in the directions of the line of reflection. So that's something key to remember. Now there are 3 big elements to this. One is what you're given, and that includes your picture, okay? So you have to be given parallel lines, and I'll show you exactly what that is, and then also a picture that shows where the point is that you're actually reflecting. 2 are steps. Now, the steps are important because you have to kind of go step by step through it. It helps you keep track of what's going on so you don't miss anything. They're not going to be required when you're talking about a quiz or a test, however. But elements that are going to be your given as well as your conclusion. And you're going to have to state as part of your conclusion what the distance is from line 1 to line 2 is, right? What that distance is, as well as what A to A double prime is, right? And that's one element. And the other is that you're going to have to state that it's of the composite reflection ends up being a translation of twice the distance. So let me show you what this looks like for like 3 different cases, okay? So if you have 2 parallel lines, the point A could be in several different spots, right? So taking a look, notice the reveal here, right? We have to be given some information. We need to be given that line 1 is parallel to line 2, and then we're being asked to prove, and then we're going to reflect first over line 1 and then over line 2, how function composition works, right? Or sorry, transformation composition works. Function composition works the same way, but you do this thing that's closest first and then this. So you're going to reflect over line 1, then over line 2. And those are kind of like the directions. So now the steps. So I've written these out, typed them out actually, and I've done this to make it, well, frankly, more legible. You guys have seen my handwriting. So the first thing we're going to do is draw a horizontal line through the point A, as soon as I can get this right. And what this is going to be the line that we're reflecting over. So the idea is that this horizontal, and we're going to assume that these are vertical, so these end up being perpendicular here. Remember, because the perpendicular distance when you reflect ends up being the same. So the steps are going to be very similar from thing to thing, but just what you label things is going to be different. So the first thing is we're going to reflect the point A over line 1. So that's going to end up being over here, right? And then we're going to label that A prime, right? Logical, yes. Reflect A prime over line 2. Now if I do that, I probably need to actually extend this if you think about it. Now remember, this is not to scale, but the closer you do it to scale, the easier it is to kind of visualize. So when I reflect it, this distance, this whole distance has got to be the same, so I'll put this way here at the end, right? That's my reflection. And I'm going to label that A double prime. Logical, right? And then I'm going to label A to line 1 equal to X. Now these distances are unknown, okay? A is somewhere between these. So what I'm going to say is that this distance from here to here, right, is going to be X. And we assume because we have this point in this line, if I put an X here, we're just talking about this piece here. Okay? That means that if I reflect this over this line, if this distance is X, this distance has got to be X. So I suspect, hey, look at that. Label line 1 to A prime equal to X also. It's got to be the same, right? Now this is where it gets a little bit tricky. This distance is X unknown. This is X unknown, but we know it's the same. It has to be because of reflection. This distance over here looks the same, but we can't be sure it is. So what we're going to do is we're actually going to label from A to line 2 the distance Y, okay? Now this next part is a little bit, now this is where you get to, this is where you earn your money. You have to like think about what you're doing. You're reflecting A prime over line 2, which means that this whole distance has got to be the same here to here, right? What is this distance? Well, it's a couple of x's and a y. So what does that mean this distance has to be? Well, it's got to be 2x plus y, otherwise it is not a proper reflection. This whole distance, because I'm reflecting over this line, right, has to be the same. Sure enough, right? Now, is that enough information? In other words, can we conclude safely what we're supposed to conclude? believe it or not, this is the end of the steps. Then the conclusion is actually down here. Just bring this up, the big reveal, right? Take a look at what the conclusion has. Like I said, I've typed it to make it more legible. What have I said? I've said the distance, or the measure of line 1 to line 2 is x plus y. And if you look at that, hey, between line 1 and line 2 is indeed an x and a y, or x plus y. From A to A double prime, right? A to A double prime is a 2x plus y plus another y for a grand total of 2x plus y. Therefore, a composite reflection over two intersecting lines is a translation that is twice the distance between the two lines. And this shows it, both with the drawing and the steps and everything else. Okay? So let's take a look at another case. This was the case where the A is between the two lines. Now we're going to look at the case where A is not between the two lines, but it's going to be to the left of the first line of reflection. That is on the far side of the first line of reflection and away from the second line of reflection. Now remember, when we're doing this, we're going to reflect over line 1 and then line 2. It's going to translate over here, right? So, same given. They're parallel lines, and we're going to do this reflection. Steps, similar. So we're going to go ahead and boldly draw in our horizontal line. That's always a good first step. And you're going to notice that the steps on this are going to be very similar from case to case, okay? Let's use blue, okay. Then I'm going to reflect line A over line 1, but just going over line 1, so that's going to end up being right around here, yes? I'm going to label it A prime. If that seems familiar, it should be. Reflect A prime over line 2. See that distance and that distance about the same, right? Label it A double prime. Then label A to line 1 X. The most number of variables you're going to need to use are 2. That is X and Y, and that's it. In some cases, you'll be able to get away with one variable. You don't want to use a bunch of different ones. So remember, A to line 1 is X. From line 1 to A prime has got to be the same, otherwise it's not a proper reflection, same perpendicular distance. A prime to this, well remember, this actually looks different, so it makes sense that it's going to be some different variable. But that means when I reflect this, I suspect this is going to be Y also. Look at that, it's Y, right? Now is this different? It turns out that's all the end of the steps, right? Is this slightly different than the last one? Yes. Is it very different? No. So let's take a quick look at the conclusion and see if there's any dramatic difference. It turns out there's not really, right? Please bear in mind that this text down here, this is going to be the same every time. It's worth memorizing, right? Line 1 to line 2, is it X plus Y? Yes, yes it is. You can look at the drawing, right? What is the distance from here to here, yeah? And then A, in this case, A all the way to A double prime. That's important, A to A double prime, right? First to last, 2X plus 2Y. Okay. So one more case. We started in between. We started to the far side of the first line reflection. Guess what we're going to do next? The far side of the next line. So same given, right? And I suspect the same first step. So these first several steps are all the same. I mean, it's a good habit to get into actually doing these out. All the steps are doing is ordering, what you're doing, so it all makes sense. Now please bear in mind, because I'm reflecting over line 1 and then line 2, I know I'm going to have an issue here. Let's see. I'm going to have to do a little bit of jockeying here, so please bear with me. I'm going to have to take you over here, you over here, and I'll move you over here. Because what's going to happen is I'm going to reflect, and it's going to go over here, but then it's going to come all the way back over here, right? So let's just be a little bit careful, extend you a little bit. Oops, I just kind of moved it. Extend you a little bit, all right? Remember, as realistic as you can, but it is a sketch, so don't get too caught up in the details. So first reflect over line 1. So about that equal distance, about there, right? So I'm reflecting, so this distance is the same from here to here, right? Label it A prime. Key thing, you're reflecting over line 1 first, right? Reflect A prime over line 2. So now this whole distance has got to be the same over here. And I suspect this is going to be labeled A double prime. Good guess, right? Or I wrote these steps. Label A to line 2 equal to X. In other words, remember we're starting with A here. We are starting with A, and therefore this means that this first unknown distance from here to here is, we're going to call it X, okay? Line 1 to line 2 is a separate distance different from x, so we're going to call it y, right? And that just represents that distance there. So now this is where it gets a little bit tricky, more thinking involved. A prime to line 1, x plus y. Remember, when you reflect over here, that distance has got to be the same here. So if this is a y and the x, this whole distance has got to be x plus y, which is telling me that that distance from here to here is x plus y, okay? All right. Now, a to a double prime 2y. Here's the y and wherefore. So when you are actually doing the reflection so from a prime to here has got to be the same from here to here, right? So what is this distance? That distance total is x plus 2y, because I have x plus y plus another y, which means this has got to be x plus 2y, right? The total distance. But look, x is already taken up for this part, which leaves how much? Well, if I've got x taken up, that means this distance has got to be 2y, right? So it adds all up. Okay, catastrophe? No. Here's why. We are actually done, and everything is fine. Our conclusion is a little bit different, okay? Line 1 to line 2 is just y. A to a double prime, remember that is the important distance. A to a double prime is 2y. Is that twice the distance? Yes. And remember, this in words is always going to be the same, right? So those are your key steps there. You'll be given this information. Steps, optional when you're taking a quiz or test, but they're good to keep in mind. And then these are required elements. You must state what the line measured distance between line 1 and line 2 is, as well as the a to a double prime, just like when we did it over intersecting lines, right? And then this conclusion is always the same, but it is mandatory, okay? So that's it for how to prove composite reflection over parallel lines.